Okay, moving on to the next question, and this is some signals related stuff. So, uh, starting off, we've got a signal with a frequency domain plot shown here. We can assume that the peaks continue to the right of a plot in the similar pattern. This is uh, we're looking at something that may be the combination of multiple things. It's a more complicated than just a single sine wave because it's got multiple frequencies. We can see that they're sort of decreasing. So this is what we saw in class where we sort of add a bunch of sine waves together, and that can give us a more complex wave, like a square wave or triangle wave, things like that. So we determine the fundamental frequency. That fundamental frequency is always going to be the first frequency we see the biggest spike at. And so the first peak that we see is at 10 hertz here. So that's all we need to do for that first question. 5 points, just find the first spike we see on that diagram above. Determine the signal period. Well, T is 1 over F, and that's going to be using the fundamental frequency. So T is equal to 1 over 10 hertz, which means that is every 0.1 second, right? Because we have 10 cycles per second. That means each of these waves needs to happen, every tenth of a second. So then for the last part, suppose this was passed through an ideal low pass filter with a cutoff frequency of 25 hertz. Which of the following figures is the most likely output signal from that filter? So let's look at our frequency diagram and say, okay, at 25 hertz, we're going to keep the things here and get rid of the stuff over here, right? Because we're low pass filtering. Low pass filter means we're going to keep the stuff below that cutoff frequency, as opposed to a high pass filter, which we would keep the stuff above, or a band pass filter where we would keep the things in between. We know that we have two waves still, or two different sinusoids going into this final output. And we still have the same information that we calculated before, which is it's at fundamental frequency of 10 hertz. So let's look at these charts and see which ones might it be. If we look at the one on the left, that's pretty clearly a single sinusoid, right? So that's not it, because we know we have at least two sinusoids put together to work. We look at the second one, it's clear that there's more than a single sinusoid happening being added together. If we look at how often it repeats, it's repeating every 0.1, so it's at the right period, right? This is T, which we're measuring, so that's an option. So let's look at the rest and see if anything else matches, but that's our likely candidate. Here we have a triangle wave, and it repeats every roughly 0.15 or 0.14. So that's a no, because T equals 0.14 seconds instead. So that doesn't work. We could also know that it's hard to make a triangle wave, or impossible to make a triangle wave with two sinusoids. And then finally, we have our other wave, which is decreasing in amplitude as we go. It does have the right period. It does, potentially have the right shape, but we see that it's decreasing, which is not something that we should get by adding two sinusoids together. This is changing the amplitude, which is not something that we should see occurring here. If we had a diagram like this, then we could maybe have an amplitude modulated signal, but that's not what we should be seeing with just two frequencies on our chart. And so we know that this is our answer here. The other three are not options. That's it for that page.